In this rather long lesson, we are going to be learning all about render elements. The topic in hand can be discussed in depth over several hours, but here we need to go through it in one lesson. If I open up the render setup window and go to the render elements tab and click on this add button, we can see a list of the available V-Ray render elements. Now, the first question we need to ask ourselves is why we use render elements in our renders. There are so many reasons for that, and as we go through some of these render elements and perform some compositing in an external application, you become more familiar with those reasons. But the main reason is that using render elements, we can break up our render into its constituents like direct and indirect lighting, reflection, refraction, and so on, and composite those parts back together in a compositing application like Photoshop, After Effects, Nuke, Fusion, or whatever you use. And having individual control over each and every component of our render gives us a lot of flexibility to adjust our final image without having to re-render the whole scene. Imagine we can take the reflection render element in our compositing application and make it stronger, or we can adjust the lighting in the scene and make it brighter or darker, or change its color maybe. We have four main render elements categories in V-Ray. We have our beauty render elements, which are the render elements that make the final beauty image. Elements like lighting, GI, reflection, refraction, speculars, and so on. We have our matte render elements, which help with the masking and selection of different parts of the image in compositing. Elements like multimatte, object, and material ID are in this category. Then we have our geometry render elements. These elements use the objects in the scene to produce geometry-based data. Passes like z-depth and velocity are in this category, and we can reproduce effects like depth of field and motion blur with them in the compositing stage. And finally, we have our utility render elements, which allow to see some information about how the rendering process is done, and also we can generate some useful render elements like ambient occlusion using the extra texture utility render element. Passes like sample rate and sample info are in this category. Now let's start with the beauty render elements and the more important ones here. Select alpha, V-Ray diffuse filter, global illumination, lighting, reflection, refraction, self-illumination, shadows, specular, SSS2, total lighting. Now coming back to the upper section, we don't have any atmospheric effects like environment Phuc in the scene, so I'm gonna skip that for now. Add V-Ray background. We don't have any caustics in the scene. Now let's add all the raw elements like raw global illumination, raw lighting, raw reflection, raw refraction, raw total lighting, and V-Ray reflection and refraction filter. And finally, V-Ray light select. Now that we have all these beauty render elements selected, let's press OK. The order you select these passes does not matter at all in compositing, just how they appear in the frame buffer. The only render element we need to adjust before starting the render is going to be V-Ray light select. The light select render element represents the lighting contribution from one or more selected lights in the scene. So we can basically break up the lighting in the scene using this render element. We need a few light select render elements for the different light sources in the scene. If I select the light select render element and come down to its parameters, we have this lights list where we can define a light or a group of lights, and this way we get to see the contribution of that particular light in this render element. If I open up my light group in the Explorer, let's first click on the add button and add V-Ray Sun. Also rename this render element to V-Ray light select underscore sun. Now add another light select render element and rename it to V-Ray light select underscore portal. Click on the add button, press H, and pick all the portal lights in the scene, the lights that are in the windows. And finally add another light select, rename it to V-Ray light select candle, and add all these small spherical lights around the candles. Now we are ready to render our scene. We can see the result of this render in the frame buffer. So first let's take a look and explain the most important beauty render elements that are used in compositing to reconstruct the final image. The first one is V-Ray diffuse filter, and in this render element we get the flat colors and textures used in the material without any lighting or shading information. Any other render elements that include colors and textures from the materials, or basically have some diffuse component, it gets that diffuse component from the V-Ray diffuse filter render element. V-Ray diffuse filter might not be used directly in compositing, but it helps to reconstruct other passes. For example, take a look at the V-Ray lighting pass, which has both the direct lighting and diffuse color information. That diffuse color information is coming from the V-Ray diffuse filter element. If I go to the V-Ray raw lighting pass, we just have the direct lighting. There is no diffuse color information. But to get the main lighting pass, we will multiply the raw lighting pass by the V-Ray diffuse filter pass, and we get our final V-Ray lighting pass. In the compositing process, we can directly use the lighting source or the lighting pass, but if we want to have even more control, we can generate our lighting pass by multiplying V-Ray diffuse filter and V-Ray raw lighting pass, and the same thing is true about the global illumination element, shadow elements, and so on. The next important pass is V-Ray lighting, and as I mentioned, this render element or pass stores direct lighting and diffuse color information. And you can use this pass in compositing to adjust the direct lighting. For example, make it darker or brighter, and as previously mentioned, this pass is generated by multiplying diffuse filter and raw lighting pass. The next essential pass is V-Ray global illumination, and here we have our indirect lighting or global illumination information, and you can use this pass in compositing to adjust the look of indirect lighting. And like the lighting pass, this render element is the result of multiplying the V-Ray raw global illumination pass by V-Ray diffuse filter pass. So if we want to have more control over our global illumination pass in compositing, instead of using the global illumination element directly, we can multiply those two previously mentioned passes together and get the same global illumination pass. Next we have reflection render element, and in this element we have the reflection information calculated from the material's reflection values in the scene. And you can use this pass to increase or decrease object's reflectivity in the compositing. The reflection render element is formed by multiplying the V-Ray raw reflection render element by the V-Ray reflection filter render element. The objects in the V-Ray raw reflection render element are either fully reflective or not reflective at all and fully black. when we multiply this pass by the V-Ray reflection filter, which has different shades of gray, and the more reflective the surface, the brighter the color, we get our final reflection pass. For example, in the V-Ray raw reflection pass, both the floor and the wall are fully reflective, and in the V-Ray reflection pass, the wall has a dark color and the floor has a bright gray color. Now when we multiply those two passes, you get your reflection pass in which the floor is very reflective because remember it had a brighter reflection color, and the wall is not that reflective because it had a darker reflection color. Hopefully it makes sense. Again, in compositing we can directly use the reflection render element, or to have more control, reproduce it by multiplying raw reflection and reflection filter passes. Next we have our V-Ray refraction render element, and here obviously we have our refraction calculated from the refractive materials in the scene. And this pass can be used to change the look of the refractive objects in compositing. And as you probably have guessed by now, the refraction pass is formed by multiplying V-Ray raw refraction by V-Ray refraction filter. And you can either use refraction pass directly or the resulting composite of raw refraction and refraction filter passes in your compositing. Don't worry if it's a bit confusing. I'll be showing you practically how to composite these passes in After Effects later on in this lesson. Next we have V-Ray specular pass, and this is the specular reflection information calculated from the material's reflection values in the scene. This is basically the reflection of light sources in the scene. Next we have V-Ray shadow pass to change the look of the shadows in the compositing, to make the shadows darker or brighter. We have subsurface scattering render element, which stores the subsurface scattering information from both fast SSS2 material and V-Ray skin material. And you can use this pass in compositing to adjust the look of subsurface scattering. We have our self-illumination render element, and here we have the illumination data from self-illuminated objects that have V-Ray mesh light, or have a V-Ray light material, or a V-Ray material with self-illumination contribution will be stored here basically. Alpha render element shows the transparency of objects in the scene as grayscale colors. Solid geometries are represented by solid white, while those areas not blocked by geometry within the scene are black. We have our background render element, which is a simple V-Ray sky here that was set in the environment slot. Another interesting render element is V-Ray total lighting, and this pass includes both direct and indirect lighting. So in composite, instead of first adding the global illumination render element to the lighting render element, you can use the total lighting render element directly instead of the lighting and global illumination render elements. And total lighting render element itself is coming from multiplying the raw total lighting render element by V-Ray diffuse filter. We have also specified a few light select render elements to isolate the contribution of different light sources that we have in the scene. We have our V-Ray light select sun, light select portal, and light select candle, and these three passes combined together will give us the lighting render element. But now we can increase or decrease the contribution of each light in compositing without having to render the whole scene again. Another beauty render element that we have is V-Ray atmosphere, and this render element include atmospheric and volumetric effects like environment, fog, and aerial perspective. And just let me actually just quickly set up a quick example and add some fog to the scene. First, let's add V-Ray atmosphere render element. Next, open up the environment and effects window by pressing 8 or from the rendering menu. And if you come down to the atmosphere rollout, you can add an environment fog. We don't want such a dense fog, so we can increase the fog distance to 800 and fog height to something like 300, so it will cover the entire view. And let's also enable scatter GI. Also in the environment Phuc nodes section, let's disable use all lights and only use the sunlight to affect the Phuc. You can select these curtains and hide them also. Now if I render the scene, we get our next render with V-Ray environment Phuc, and this is our V-Ray atmosphere render element, and we can simply make the atmospheric effect less or more intense in compositing, or even change its color tint if we wanted to. Perfect. Let me close the frame buffer, unhide the curtains, and in the environment and effects window, select the V-Ray environment Phuc and disable it for now. And in the render elements tab, delete V-Ray atmosphere render element. Next we have our matte render elements, and these render elements help with demasking and selection of different parts of the image in compositing. And the way these matte render elements are used in compositing is, using them you can isolate certain object or surface with a certain material and apply the adjustments that you want, like for example any color correction, specifically to those isolated parts. Imagine if you want to change the color of the walls using a hue and saturation effect in Photoshop or After Effects. Using these matte elements you can mask the hue and saturation effect to only affect the wall and not the rest of the image. We have a few essential matte render elements. Let's add the more important ones. We have multi-matte render element, which is the most important one. We have V-Ray material ID or V-Ray MTL ID. We have V-Ray object ID, V-Ray render ID, and V-Ray wire color. Now press OK. For now, let me select the multi-matte element and rename it to multi-matte element underscore 01. Let's add a second multi-matte element and rename it to multi-matte element underscore 02. And change the RBuff ID to 4, GBuff ID to 5, and RBuff ID to 6. Sorry, BBuff ID to 6. In a moment I explain the reason for doing this. And if I render the scene, we have our matte render elements in the frame buffer. We have V-Ray object ID, which isolates individual object based on their object ID. You can see in the object ID render element, the walls, the floor, the chair, the desk, they all have different colors based on their object ID. In this case, if I select this wall and right click and choose object properties, the object ID for this wall is set to 1. If I select the floor and go to its object properties, I have assigned 3 as its object ID, and you can simply change it to whatever number you want. And the chair, for example, has an object ID of 4. So all the objects in the scene with the same object ID will have a differentiating color. In this case, for example, all the objects with the object ID of 4, like the chair, will have a blue color assigned to them in the object ID path. Now, very simply, in any compositing app like Photoshop, you can isolate the object that you want and adjust it without affecting other objects in the scene. And the object with their object ID set to 0 will appear black in the render element. We have material ID, and this path is basically doing the same thing, but instead of isolating the objects based on their object ID, it does so based on the material IDs. If I go to my material editor and pick the material from this frame object in the scene, for example, and right click on its name, the material ID for this material is set to 9, and the wall, the floor, the chair, the lampshade, they all have different material IDs. And the materials with the same material ID will be having the same color in the material ID render element. We have our render ID render element, which creates selection mask based on the node handle of each object, and we have the wire color render element, which stores the wireframe color of the object as set in 3ds Max Scene, and you can create masks based on the wire color of the objects in your compositing application. And next we have our multi-matte render element, which is the most important one and basically the most popular one, the easiest one to use in compositing applications to isolate the objects. The multi-matte render element creates red, green, and blue selection masks based on object IDs or material IDs. So this is our multi-matte render element 01 and this is 02. If I go to the render setup window again and select the first multi-matte render element and take a look at its options, we can define only 3 object or material IDs. Right now we are isolating objects with their object IDs set to 1, 2, or 3. You can see the R buffer ID is set to 1, so the objects with the object ID of 1 will have a pure red color. G buff ID is set to 2, so the object with their object ID set to 2 will be green, and B buff ID is set to 3, so the objects with their object ID set to 3 will appear pure blue in the multi-matte render element. With multi-matte, a single R, G, or B channel can be used directly as a matte, eliminating the step of selecting the color manually in the compositing software. This ease of use makes multi-matte a popular choice, and I'm going to show you in After Effects in a moment how easy it is to actually isolate an element using the multi-matte render element. If you want these IDs basically to be based on material IDs and not object IDs, you can enable Ease Matte ID option. You can add additional multi-matte render elements to isolate the other objects or material IDs. In this case, the second multi-matte render element isolates the objects with their object ID set to 4, 5, or 6. So that's about the most important matte render elements. Let's explore the utility render elements. We have V-Ray denoiser, V-Ray DR bucket or distributed rendering ID, V-Ray extra text, V-Ray illuminance, V-Ray sampler info, V-Ray sample rate, V-Ray unclamped color, and V-Ray option RE. First, let me select V-Ray extra text and use a V-Ray dirt map as its texture. Also select the sampler info and change its type to UVW coordinates. If you render the scene, the result would be the render named utility render element. First, we have V-Ray denoiser, and we have used it a lot in this course, and it removes noise. It's that simple, and it's doing such a great job. The denoising operation detects areas where noise is present and smoothes them out. And if I compare the original beauty pass with the denoise pass, you can see how clean it gets. You are not supposed to use a high noise threshold value in your image sampler setting and assume that V-Ray denoiser can clean up the excessive noise. If you do it this way, you are going to get obvious artifacts in the denoiser pass that makes it useless. You are supposed to use an acceptable noise threshold value in your image sampler, maybe something like 0.01 or 0.02, and leave the high frequency noise for the denoiser pass. And if I go to its settings, we have a bunch of presets: mild, default, strong, and custom. Default basically applies a mid-level denoising, mild applies a more subtle level of denoising than the default preset, and strong applies a stronger level of denoising than the default preset. Custom allows the strengths and radius parameters to be set to custom values. And strength is determining how strong the denoising operation will be, and radius specifies the area around each pixel to be denoised. A smaller radius will affect a smaller range of pixels, while a larger radius will affect a larger range, which will increase the noise removal. And we have update, which updates the denoiser pass based on the adjustments that we have made here. Let's maybe set the preset to mild and click on the update button. After a few seconds, we have an adjusted denoiser pass. Also, this pass creates some extra render elements like noise level and the focus amount to make the denoising operation possible. We have the distributed rendering ID render elements, or V-Ray DR bucket, which shows the name of the rendering machine that rendered any particular bucket when distributed rendering is used. In this case, we haven't used it, so this render element is black. We have our V-Ray extra texture or extra text, and this render element renders the entire scene with one texture mapped onto all objects in the scene. In this case, we used a V-Ray dirt map as the texture, and as you can see, it has been applied to all the geometries in the scene, and it gives us a beautiful ambient occlusion pass that can be used to enhance the details in the image in compositing. And you can drag the V-Ray dirt texture used as the extra texture and edit it in the way you want in the material editor. We have V-Ray Illuminance. The Illuminance render element is a grayscale or color image that displays the illumination in each part of the scene. We have V-Ray Sample Rate. The sample rate render element displays the work being done by the image sampler as a red, green, and blue image. We have discussed this pass and how to read it and use it in your image sampling in the image sampling section of the course. So you can check that lesson out if you are not sure what these colors mean. The sampler info render element provides information about various aspects of the shaded points, such as position, normal, bump normal, reflection, refraction, vectors, UVW coordinates, and so on. In this case, if I select the sampler info render element, we set its type to UVW coordinates, and that is what we see in the frame buffer. And these render elements can be used for diagnostic purposes or retexturing and relighting in compositing applications. Which unfortunately can't be covered in this limited time that we have, but you can search the web and see how these passes can be used in compositing. And we have V-Ray Unclamped Color. The unclamped color render element stores the images, colors, and textures with colors that have not been clamped. A number of settings and parameters in V-Ray, we know that they actually clamp colors so they fall within a particular range. This render element provides the unclamped version of the image. In the render setup window, we have V-Ray option RE or V-Ray render options, and this render element does not generate any render element, rather it controls some internal settings for V-Ray that are otherwise inaccessible. For example, using the EXR compression dropdown, we can specify the compression method when writing open EXR files through the V-Ray raw image file option in the V-Ray frame buffer settings. And finally, we have our geometry render elements. Geometry render elements rely on geometry to generate the render elements, and they include bump normals render element, normals, velocity, Z depth, and wire color. Wire color is technically a geometry render element, but as its main purpose is to aid masking and basically the selection process, I discussed it under matte render elements. Now let's add these render elements. So let's add these 4 render elements. First bump normal, then normal, velocity, and Z depth. And press OK. Select the Z depth, set the Z depth min to 400 centimeters and Z depth max to 770 centimeters. We talk about the reason in a second. Also, if I go through the timeline, we have this very simple animated sphere which helps us to visualize the velocity render element. Let's stop it at frame 32 and take a look at the resulting render in the frame buffer. First, we have our bump normals render elements. This path stores the camera view as a normal map. The normals are generated using screen space, which uses the XYZ orientation of the camera view. And these render elements can be used to relighting purposes in compositing, especially the light that comes from a certain direction and needs to be adjusted. We have V-Ray normals, which is a render element that stores the camera space normal map using the geometry's surface normal. The normals render element is useful for adjusting the lighting in the composite. We have V-Ray velocity. This render element is a color or grayscale image that stores velocity information about objects that have animation in the scene, and this path can be used to produce motion blur in compositing. For example, in After Effects, you can use a plugin like a Smart Motion Blur, define this velocity path as the motion source, and this way add motion blur to the sphere without having to re-rendering the motion blur from V-Ray. And finally, we have V-Ray Z depth. This render element provides information about each object's distance from the camera in the current view. You can see in this case the polygons or objects that are closer to the camera are white, while those far away from the camera are black. We can control where exactly this white to black transition happens over the distance from the camera using the Z depth min and max value. In case of Z depth min, objects up to this distance from the camera will render as white, and in case of Z depth max, objects further than this distance from the camera will render as black. And obviously the transition from white to black happens from the distance defined in the Z depth min to the distance defined in the Z depth max. If I go to the top view and select my physical camera, you can see it has a target distance of 535 centimeters. We set the Z depth min to 400 centimeter, and if I put this value here, you can see this is the point before which all the objects will be white. And from this point, the Z depth map starts to get darker until it reaches the Z depth max, which is 770 centimeter. And if I put it here as the target distance, you can see it is the end of the room. And from this point on, everything is black in the Z depth map. And you want to make sure that all of your geometries in the camera view are located in a distance between the Z depth min and the max, so you can successfully reproduce effects like depth of field in your compositing application using this render element, obviously. Now let's set the target distance back to 535 centimeters and make sure the timeline is on frame 0. Now we have discussed all the render elements, and it's time to do some basic compositing in After Effects using these passes. In the Render Elements tab, I'm gonna first delete some of the unnecessary passes. From bottom to top, we can delete all the passes from V-Ray Velocity to V-Ray Illuminance, and also V-Ray Denoiser can be deleted. We can delete V-Ray DR buckets and render ID and wire color. Okay, we can delete all of these passes that we just selected. For the final render, let's go to the Common tab and change the width and height to 1200. And in the V-Ray tab, change the type to bucket. Set the max subdivs to 32 and noise threshold to 0.007. Also in the Frame Buffer tab, enable V-Ray raw image file and go to the final render folder for this lesson, which is located in the render output folder of the project files. Name it a blue room or something like that. Use OpenEXR. I'm not gonna enable 32-bit output, so we are basically outputting a 16-bit image. Now we can press save. Also, let's enable separate render channels. Go to the final folder again. And we have another folder called separate. Go in there and let's name it separate blue room. Choose OpenEXR as a format, press save, and in the configuration window make sure the format is 16-bit and press OK. In the GI tab, let's set the irradiance map subdivs to 85 and interp samples to 25 and set the light cache samples to 1500. Perfect. Now we can render our scene and start compositing in After Effects. Here we are inside Adobe After Effects. Obviously, we don't have the time to go through every trick in the book, but I'll be trying to cover all the basic foundations that you need to start your compositing journey. First, double-click in the project panel and go to where you have saved your render. In this case, we need to go to the final render folder of this lesson located in the render output folder of the project files folder for this course. We have this EXR file called Blue Room and it contains all the render elements. So let's double click on it and import it. Let me double click again in the project panel and go inside the separate folder. And here we have all the render elements in separate EXR files. Let's select all of them and click the import button, and while they are selected in the project panel, also let's drag them into a new folder. And we can name this folder separate or whatever you want. Sometimes the extractor effect in After Effects can be a bit buggy and might miss some render elements in the EXR file that contains all the passes. So in that case, these separate render elements can be very useful. Now, first, let's create a new composition based on our main EXR file. And rename the composition to basic composition or anything that you like. The next thing is to make sure we are working in the right color space. So from the file menu, open up the project settings window. In the color settings section, change color depth to 16-bit. If you remember, we rendered out 16-bit images. Change the working space to sRGB and enable linearize working space and press OK. In the effects and presets panel, search for the extractor effect and apply it to the layer. Now if you click in this empty space in the effects control window, we get the channels window where we can extract different render elements from the original EXR file. The first render element we need is lighting, so let's select V-Ray lighting and press OK. Now we have V-Ray lighting render element in the composition. Also, let's rename the first layer to lighting so we don't get confused. To rename a layer, simply select the layer and press enter, type the new name and press enter again to confirm the new name. Next, we need the global illumination render element. So let's duplicate the lighting layer by pressing Ctrl D. Rename it to GI, and from the extractor effect, select the global illumination render element. Now we can change the blending mode for the GI layer to screen. We can change the blending mode for the first layer to screen as well. So let's do that. But as it is the first layer, it doesn't really matter to use normal or screen render element. Next, we need our reflection layer. So duplicate the GI layer, rename it to reflection, And from the extractor effect, select reflection render element and press OK. Now let's add the refraction render element. The same process, duplicate the reflection layer, rename it to refraction, choose the refraction render element from the extractor, and now we have added our refractive surfaces to our render. The naming of the layer really doesn't matter, I'm just trying to stay organized here. You can see the render is coming together, and as we are duplicating the previous layers, the new layers blending mode is also set to screen. If not, you need to change blending mode to screen manually. You just need to add this layer together, basically, nothing very specific going on here. Now it's time for the specular render element, so duplicate the refraction layer, rename it to specular, and choose V-Ray specular render element in the extractor effect. Next, we can add the subsurface scattering render element. So the same process again, duplicate the layer, rename it to something like SSS, and select V-Ray SSS2 render element in the extractor plugin or effect. And finally, it's time for the self-illumination render element. Duplicate the layer, rename it to self-illumination, and choose V-Ray self-illumination render element. And here is our final render without the background. Now let me turn off the layers and go through the render elements we used to reconstruct our final render. First, we added our lighting render element, then global illumination, next reflection. After that, we added refraction, then specular, subsurface scattering, and self-illumination. Now we are back to our beauty render basically. In this stage, we can do a lot. For example, I really want to have a much stronger scattering effect, so I can simply select the SSS layer, apply an exposure effect, and increase the exposure value to something like 1. Now we get a stronger subsurface scattering effect very simply without having to re-render the scene. Or I can select my GI layer, press T, and decrease its opacity to something like 50. Now we have a darker indirect lighting. Let's set the opacity for the GI layer back to 100. The next thing I want to show you is how to use the light select render elements to control the lighting of the individual light sources in the scene. In the project panel, let's duplicate the basic composition and rename it to light select, and double click to open this new composition. Let me hide all the layers except for the lighting layer. Now we want to recreate this using the light select render element. We want to recreate the lighting render element using the light select render element. So hide the lighting layer as well, duplicate it, and rename it to light select sun. And in the extractor effect, choose V-Ray light select underscore sun and make the layer visible. And here we have the lighting contribution from only the sun. Duplicate the layer and rename it to light select underscore portal, and choose the light select portal render element from the extractor. Make sure the blending mode is set to screen, and here is the lighting contribution from the portal lights in the windows. And finally, duplicate the layer again, rename it to light select underscore candle, and choose the relative render element from the extractor. And there we have the lighting from the candles. Now I can have real-time individual control over my different light sources even after the render has finished. I can select the portal lights layer and decrease its opacity, for example, or set its opacity to 100, duplicate the layer, and this way make the light even stronger in the scene. For now, let me just delete the duplicate here. And now if I turn on the other layers, we are gonna have the same image as our final render, even though the light select passes that we exported have some specular information because their mode in the render elements tab in 3ds Max was set to normal, I think. I think the light select render elements also has a diffuse mode that won't include any specular information, but in this case we can manually turn off the specular layer even though it doesn't make any specific difference in the scene. As I was explaining different render elements, I mentioned that, for example, global illumination render element is formed by multiplying V-Ray raw global illumination render element with the V-Ray diffuse filter render element. Now let's practically do that. And V-Ray lighting is formed by multiplying V-Ray raw lighting and by V-Ray diffuse filter. So the same thing here. I'm going to explain it for global illumination, and you can do the rest on your own. Let's create a new composition based on our original EXR file and name this composition something like GI reconstruction. Again, apply the extractor effect to the layer here. Click in this empty space in the extractor effect and choose V-Ray raw global illumination. Also, let me rename the layer itself to raw GI. Now we need our V-Ray diffuse filter under element, so duplicate the layer, rename it to diffuse filter. In the extractor, choose V-Ray diffuse filter render element. And set its blending mode to multiply. Now we have reconstructed our global illumination render element. Now let's use this reconstructed GI render element instead of our original GI render element. So in the project panel, duplicate the basic composition and rename it to something like complex composition. I don't want to change the basic composition for now, and open up the complex composition. Now we can turn off our GI layer in this composition and instead use the GI reconstructed composition as the GI layer. Just make sure its blending mode is set to screen and preserve underlying transparency is enabled for the layer. Here we can do a lot. For example, we can tint our global illumination solution without affecting any diffuse color in the scene. So in the GI reconstruction composition, hide the diffuse filter layer for a moment and apply a curve color correction to the GI layer. Just go to the red channel and make the image a bit warmer. Now if I turn on and off the curve effect, you can see we get a warmer GI solution. And if I get back to the complex composition, you can see how this change made the overall image a lot warmer. To compare it quickly, let's take a snapshot. Disable the GI reconstruction and enable the original GI pass. And now if I click on the show snapshot, you can see how it made the scene warmer without affecting the other colors in the scene and tinting those colors basically. Now let's hide the GI layer and unhide the GI reconstructed or reconstruction composition as the GI layer. And in the GI reconstruction composition, disable the curves correction. Another thing I want to show you is how to use the multi-matte render elements to isolate a certain object in your image and adjust it the way you want without affecting other objects. In this case, let's change the color of the wall. We can go to our basic composition and isolate the wall and adjust its color. And I'm going to show you how to do that very simply, but I'm going to do it on a more fundamental level first. If I go to my complex composition, you can see that the color of the wall is coming from the lighting and the GI pass, and mainly the GI pass. We have reconstructed our GI render elements now we need to reconstruct the lighting path as well, but I'm gonna leave that for you to save some time. The dominant color is coming from the GI path, so let's take care of that first. Let's go to the GI reconstruction composition. We want to change the color of the wall, so the first thing we need to do is to isolate the wall, and we are going to do that using our first multi-matte render element. So let's bring in our original EXR file, rename it to mask for the wall maybe, apply extractor, and select multi-matte element 01. Now in the effects and preset panel, search for an effect called set channels, apply it to the layer, and in its controls we are only interested in the red channel, so let's turn off green and blue channels in the effect. Also make sure the red channel is also the source for the alpha channel in the set alpha to source dropdown. Great, now we have isolated the wall. We'll create a new adjustment layer from the layer menu and make sure to place it under the mask layer. Apply a hue and saturation effect to the adjustment layer. Right now, if I change the hue, it changes everything. But if I change the track matte for this layer to the alpha matte from the above layer, now it only affects the wall. But if I turn off the diffuse filter layer, you can see it also affects the raw GI layer as well. And we don't want that. We just want to change the color of the wall in the diffuse filter layer, right? In this case, the solution is very simple. Right now, the blending mode for the raw GI layer and diffuse filter layer is set to normal and multiply. However, because we are multiplying these two layers together and we don't have any other layer beneath them, we can simply change the blending mode for the raw GI layer to multiply as well. And the order of these two layers really doesn't matter in this case. It doesn't matter which one is above which. So I can set my raw GI layer on top of everything, and this way the adjustment layer only affects the diffuse filter layer, because adjustment layers only affect the layers that are beneath it. Now we can change the color of the wall the way we want. In this case, let's use, I don't know, maybe something like 322 degrees as the hue, a beautiful green color. There we have it. We have changed the color of our wall. Now if I go to my complex composition, you can see the wall has a new color, but we are still getting some of that original color from the lighting path, and we need to adjust that too. And I'm gonna leave that to you. Simply reconstruct the lighting path by multiplying the very raw lighting and very diffuse filter, isolate the wall and adjust its color the way we did it in the for the GI path, and use the resulting comp instead of the lighting layer in the complex composition. Or we can simply select the adjustment layer and the mask layer, press Ctrl and C to copy them, get back to the basic composition, press Ctrl and V to paste those two layers, make sure the adjustment layer is below the mask layer. And now we have changed the color of the wall, and it works just nice and fine here. Let me just rename this adjustment layer to wall CC, which stands for color correction. The final thing I want to show you is how to use the Z depth render element to generate beautiful depth of field effects in After Effects. It is very simple. In this simple composition, let me first turn off the adjustment layer. We don't need it for now. Sometimes the extractor plugin has problems with the Z depth path, so I'm gonna use the separate paths that we saved out. So in the project panel, open up the separate folder and bring in the Z-depth pass. And here in the composition, we can see our Z-depth render element. Now we can go ahead and hide this layer, as we only need to use it as the source for another layer. Add a new adjustment layer, and let's name it depth of field or whatever you are comfortable with. In the effects and preset panel, I'm gonna use a plugin called depth of field from Phuc, which is a commercial plugin well worth the money. If you don't have it, you can use the native lens blur effects, and it's doing a similar job, but this plugin is, in my experience, is doing much better job, and it really produces beautiful depth of field effects, and it gives you tons of controls to control the iris shapes and stuff like that, which makes it amazing. In this plugin, first you need to define the depth layer, which is our Z depths. There we go. Make sure to define this. Radius controls the amount of blur that you want. Let's set it to 10 for now. Just so we can obviously see where is in focus and where is out of focus. Using select depth, you can define the focus distance of your camera simply by clicking on the object that you want to be in focus. In this case, let's select the books. Now the books and everything in the same image plane will be in focus. Basically everything that has the same distance from the camera as the books will be in focus, right? And now it's basically when you click here, the plugin is actually picking the shade from the Z depth pass that we have defined as the depth of field layer. And this way, basically everything that has the same shade and is in the same image plane and has the same distance from the camera will be in focus. If I select this candle, they will be in focus, or if I select this frame here, the books, the candles, and the chair will go out of focus. I mean, we are using an 80mm lens, so we don't have much perspective and much depth, so but we still getting this beautiful depth of field effects. Okay, let's make sure the books are in focus for now. The depth of field plugin works really amazing, and there are so many other options in this plugin to adjust and get really good depth of field effects, but this is enough for now. For now, let me disable depth of field as well. And finally, let's duplicate the lighting layer and rename the new layer to background and put it beneath everything. And in the extractor, choose the background render element. And here is our background. Obviously, if the background appears a bit darker or a bit brighter, you can simply apply an exposure effect and decrease or increase its exposure to make it the way you want. We can turn on our depth of field layers as well, maybe. I mean, there are so many other things that we need to discuss in compositing and how to do it, but unfortunately, we can't make this lesson any longer. It's already very, very long, but hopefully you can continue by searching on the web and watching other tutorials and get your compositing going on. So in this lesson, we learned about render elements and how to composite them inside After Effects.